unit in geometry. And so there are three different transformations that we want to look at: translations, reflections, and rotations. Let's look at translations first. So I'm up here, and a translation is nothing more than a move, right? We take x comma y, and then we do something like x plus 7 comma y minus 4. It's telling you to take your shape, whether it's a line, a triangle, or a rectangle, whatever shape it is, and take the x values and add 7 to them, which is going to move it to the right, and take the y values and subtract 4 from all of them, and that will move it down. Okay, so a translation is nothing more than just taking an object without changing its orientation at all and just moving it right or left and then up or down. I guess we could also go over some of these words you might see. They talk about a pre-image and then to an image. So this would be like the original rectangle, and then this would be after, the image would be then after you did the translation. Sometimes they talk about mapping the pre-image to the image. All of these, translation, reflection, and rotation, are all rigid. And what that means is that the pre-image, the first one, is congruent to the image. So that what that means is if you do a move, whether you're a reflection or rotation, the original shape, the pre-image, and the final shape, the image, are congruent, meaning they are the exact same shape. Same length of sides, same angles, same area, same perimeter. Nothing has actually changed. Now, they might be tilted a little bit, they might be in a different quadrant, they might be flipped upside down, but they are the exact same shape. And so all three of these things are rigid transformations. So translations are the easiest ones. They're just move. When we talk about a reflection, we're talking about the mirror image. And really, there are only 6 kind of ideas that we can do. We can take an image and reflect it over the x-axis, which is this. We can reflect it over the y-axis, which is vertical. We could reflect it over a random vertical line, which is, for an example, is like x equals 3. X equals 3 would be this line. All the x values are 3, so it's the line. We could reflect it over a horizontal line. Y equals 5 would be an example. We could reflect it over the diagonal, y equals x. We could reflect it over the negative diagonal, which is y equals negative x. Regardless, what we do to do a reflection is we take the mirror image perpendicular over that line. So if I'm up here, right, I'm going to get reflected down here. If I'm way over here, then I'm going to get reflected way over here. Those distances match. So all you have to do is basically count how far you are away from the line of reflection and then flip over that line. And again, if you're flipping over these, you reflect across them diagonally. So here and then over there. And again, these are only 6 cases. So you have to understand how to graph x equals 3 and y equals 5 in order to be able to reflect over those lines. Rotations, we typically are only going to do 90-degree rotations. And those are really just turns, right? We're going to turn clockwise, or we can turn counterclockwise, right, against the hand of a clock. Here's an example of a 90-degree rotation clockwise, right, going from the first quadrant down to the fourth quadrant. So it's going to take a point like 2 comma 5 and make it 5 comma negative 2. So this one went over 2, up 5. This one's going to go over 5, down 2. You can check out the slopes of these two things. This would have a 5/2 slope, and this would have a negative 2/5 slope. Opposite reciprocal slopes are 90 degrees, which is the same thing as being perpendicular. And you can kind of just visually see, you're going to take this whole quadrant and tilt it down here. And so it was high and close, and so now it's just going to be far and close. If you wanted to do a 180-degree rotation, you actually have 2 choices. Choice 1 is you just do 2 separate 90-degree rotations, or you can actually do a double reflection over both the x and y axis. So you can flip, and be the same thing as doing 2 90-degree rotations, and we did go over that in class and kind of showed examples of that. If you have compositions, that's just doing more than one transformation. And the order sometimes matter, and sometimes it's actually the same thing. For instance, you can move something and then reflect it, or you could have reflected it and then moved it, and you'd end up actually in the exact same spot. But that's not always true. It really just depends, and you got to think through whether the order matters or not. We also introduce prime notation, and so this is A, which is the pre-image, and then you have the next image, image, image. So you have A, which is like the starting shape, and then you have A prime, A double prime, A triple prime. So this would be if you did 3 separate transformations. So you could have like took an A and reflected it to form A prime, and then maybe you rotated it to find A double prime, and then you translated it to find A triple prime. Okay? And again, composition is just doing, more than one of the big 3: moves, mirrors, and turns. Okay? And then the last thing, if we're talking about reflection, then we can talk about lines of symmetry. And so if you look at this arrow, we could draw a dot, 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 and if we took that arrow and reflected it about that line, we actually would get the exact same shape. And there'd be no other point where we could do that. And then this hexagon, we actually can take the 6 lines I have drawn, and you could do, you could reflect, and you'd have the exact same shape. So it's got 6 lines of symmetry. And then we have rotational symmetry, and in this case, I just drew a hexagon. And so if you take 360, which is all the way around, we can actually just divide it by 6, right? Divide it by the number of sides, which is also the number of vertices, which is also the same number of angles, and we can rotate by 60 degrees, right? Basically 1/6 of a full rotation. And so what happens if you rotate this 1/6 of a total, you just take this point here and plop it up there, which moves that one to there, and that one to there, and that one to there, and that one to there. So it's actually the exact same shape. So this guy has got 60 degree and any multiple of that. So you could do 60, you could do 120. 120 would just take this guy all the way to this guy. You could do 180, you could do 240, you could do 300, or you could do 360. Of course, you can take any shape and rotate it 360 degrees, and you're just throwing it all the way around. But pretty easy for these regular polygons to kind of think about, the multiples of 60 for a 6-sided thing, for like multiples of 45 for an 8-sided thing, and so on. Okay, so we do have rotational symmetries, lines of symmetries, but the big part of this unit is just being able to do the 3 main transformations: translations, reflections, and rotations. And we have to be able to typically rotate about the origin, but we really can rotate about any point. And we have to be able to do clockwise and counterclockwise. And then certainly I can just put them all together and make a composition of them. But you have a practice test that's on Canvas. The practice test and the test are going to be really similar. And again, this unit, I'm not saying it's an easy unit, but it is straightforward. There are absolute things you have to be able to do in order to be successful on the test. And I think if you look at the review and the practice test, they're pretty straightforward in terms of what we need you to be able to do.